Hi, welcome back to C Programming. I'm your Dr. Vasu. Let us see a typical problem in addition of matrices. If you want to learn this and many more interesting topics, please do subscribe this channel. If you like this video, please hit the like button. That will keep me motivated to create many such videos in the future. Now let's see what this typical problem is. Addition of two matrices. When you want to add two matrices, it must have both the matrices must be having same number of rows and same number of columns, and need not be the rows and columns in a matrix need not be same in the same matrix. So here the logic is the rows in the first matrix and the rows in the second matrix must be same, and also the columns in the first matrix and the columns in the second matrix must be same. Then only it should proceed and add the matrices. Else it should indicate some error, what that problem is. So here, let us see, let us take two matrices. Say A and B are two matrices, empty matrices. We are not going to give the data initially. So, and these are declared as 100 by 100 matrices, right? The size is very big, of course. And it doesn't mean that matrix need not be 100 by 100 only. We can constrain them. We can restrain them to our requirement. We can use up to say 10 by 10 or 3 by 3, even 2 by 2 matrix also. So the values need not be 100. Let us see how it is and what happens. The resultant matrix is 100 by 100, of course. And coming to the other variables, I and j are used for manipulation of rows and columns in the matrices. M and N are the rows and columns of A, and P and Q are the rows and columns of B. Now, we are going to take the data, input the data of matrix A. That is, we are going to take the rows and columns of A here and assign them to M and N. Now, similarly, take the data of B and assign them to P and Q. So, once the data, the number of rows and columns of both the matrices are known, let us have a condition. Let us check this condition of the rows in the first matrix and the rows in the second matrix. M and P must be same, right? And N and Q, the columns in both the matrices must be same. Then only it should proceed. Then only it should come into this bracket, right? It should come into this loop. Now, once this condition is satisfied, it is going to ask the other data, the data of A. So, enter the elements of A. Now, we use the I for rows, and here we know the number of rows in the matrix A is M. So, this loop continues for M times. And similarly, the columns in A or N. So the loop is going to continue for N times. Now input the data of a particular each and every element in the matrix A. So they are assigned to A, I, J. So corresponding elements in the matrix A in the form of array we are going to enter. So this is regarding the matrix A. Similarly, the matrix B also takes place in the similar fashion. Only thing is here the number of rows and columns are taken as P and Q, right? P and Q are the number of rows and columns in the matrix B, and the data input is assigned to the elements of B here with the help of B, I, J. Now the data is ready. Now we can do the addition. Here we are going to manipulate, or the addition takes place for M number of rows. M and P are both are same. So here, whether you give M or P, it doesn't matter because both are same. We know when these two and these two are same, then only this process is continuing. That's why M and P must be same. So whether you give M or P here, it doesn't matter. Similarly, the number of columns here, N and Q, whether you give N or Q, it doesn't matter. Both are same. So here, the addition takes place. The elements of A and B, the corresponding elements of A and B are added and assigned to C here, the resultant matrix. So here, this is the addition takes place. Now we are going to display both the matrices given. A matrix A is displayed here with the elements name. A, I, J values are displayed. Similarly, the matrix B also are displayed here. Of course, here we are going to use M and N as the rows and columns of A. P and Q are the rows and columns of B. Now the resultant matrix coming to C, I am using a M and N here because whether you use M and P both are same. That's why whether you use M or P, it doesn't matter. Similarly, N and Q are both are same. So N and Q are used here. So the resultant values of matrix C are displayed here. Now complete the program. And up to here, the if loop continues. If that condition was satisfied, then only all this process takes place. If that condition of number of rows and columns is not satisfied, then it directly comes out of that one and executes this one. Else, condition is, it says it's not possible or some error. It indicates this error. And close the program, compile it and execute. Now it is asking for the data of A and B. I have given 2 by 2 as the data of number of rows and columns as 2 by 2 of A and 3 by 3 of B. It is not possible to add both this type of different rows and different columns. So it should say that it's not possible. It says that. Suppose I have taken a 2 by 3 of A and a 2 by 4. That means number of rows are same in both the matrices, but the columns are different. So what happens? It is also not possible. So it's not possible. Now let's take a 2 by 2 matrix. Both are 2 by 2 matrices. And then because this condition, number of rows are same, number of columns are same. That's why it enters into that loop here. And now it is asking for the data of A. Let us give the value of data as 1, 2, 3, 4. It asks for the data of B. Let's give 6, 7, 8, 9 some values here. It displays both the matrices A and B, right? Now the resultant matrix is 6 plus 1, 7, 7 plus 2, 9, 8 plus 3, 11, 9 plus 4, 13. Like this, the resultant matrix occurs. Okay, so this is when you take the data as 2 by 2 matrices. Suppose continue the same, execute the same program. And now let's give a different set of data. Say it's a 3 by 3 matrix. A is a 3 by 3 matrix. B also is a 3 by 3 matrix. Now what happens? It asks for because the number of rows as well as the number of columns are same. It enters into the loop and now it asks for the data. Now the data of A are given here like this. Similarly, the data of B. Now, once the data is ready, it executes and gives out the output, the display of A, display of B, and the resultant matrix C. Here, if you see, just it all depends on the type of data you give. 9 plus 1 is 10, 8 plus 2 is 10, 7 plus 3 is 10. Like this, the corresponding values are added and we get the resultant matrix. Now here you may get a doubt whether in both the cases we have taken a square matrix, right? Is this works only for the square matrices? No. Suppose we give a different type of data. If this is not a square matrix, I give a 2 by 3 matrix for A and a 2 by 3 for B. These two are not square matrices, but the number of rows in both the matrices are same. Number of columns are same. Okay. Now let us see what happens. Now, because this condition is satisfied, it goes in. And now it asks for the data. Enter the data here. 2 into 3. So 6 elements. So data elements are given. And coming to the B, different set of data is given here. And now all the data of A and B are given. Now it gives out the display of A, right? 1, 2, 3, 4, 5, 6. Display of B, 100, 200, 300, all this. Now the addition of these two, 100 plus 1 and 101, 200 plus 2, 202, 300 plus 3, 303. Like this, the data is displayed. So this is a typical program. Before you do any such sort of matrix additions or subtractions, we need to check whether the number of rows and columns are same or not, like this. So once that condition is satisfied, we can further proceed. So this sort of a typical program we can understand like this. So in the next video, we are going to see the sorting of an array, and I hope you had understood this topic very well. And if you have any queries or suggestions, please do comment. Thank you.